Good afternoon, advanced algebra students. I hope you're doing fantastic. I'm looking forward to doing another lesson with you. This is going to be kind of confusing, but we have a lesson 3.3a, but this year with the distance learning, we're not doing the 3.3b. So some of you may say, well, how come there's an A but not a B? We normally do have a B. We're not going to be teaching it this year because there are topics that are not really essential to do in advanced algebra. So keep that in mind when you do the homework. You're going to look at the assignment sheet and only do the problems associated with 3.3a. So we're going to talk about some what's called identities in this lesson. So an identity is a mathematical statement that equates two polynomial expressions. So I'm just going to start going through some of these. The first one is called a difference of squares. So sometimes we call this a DOPS or DOPS, difference of perfect squares. And this identity tells us that if I have a squared minus b squared, I can factor that as a plus b times a minus b. So for example, if I have, and I think I'll just do it right underneath here, 25x squared minus 36y squared, I can factor that if I first identify what is my a and what is my b. So this would be 5x squared, and this would be 6y squared. So because my a is 5x and my b is 6y, I can rewrite this as 5x plus 6y times 5x minus 6y. And so I can use that identity to factor. Now, there's another identity called square of a sum. We don't use this one as often as we use the DOPS, but it's telling us that if I take a plus b and square it, I get a squared plus 2ab plus b squared. Essentially, if I FOIL a plus b times a plus b, this is what I would get. So for example, let's say I have 3x plus 4y squared. If I identify that my a is 3x and my b is 4y, I can use that information here and write this as 3x quantity squared plus 2 times 3x times 4y plus 4y squared. I do have to remember when I'm squaring to apply that power to both terms. So this is going to be 9x squared plus 24xy plus 16y squared. Now, there are two other factoring tools that we're going to learn here. The difference and sum of cubes. So let's look at the difference of cubes. So the difference of cubes is exactly what it sounds like. It is two cubes with a minus sign between them. So let's go ahead and write down what we can factor this as. This can be factored as a minus b times a squared plus ab plus b squared. Okay, now let's do a specific example. Let's do 8x cubed minus 27. It can be helpful to identify what is our a and what is our b. So in other words, what would I cube to make 8x cubed? The answer would be 2x. And then what would I cube to make 27? The answer would be 3. So if I plug 2x in for A and 3 in for B, I would have 2x minus 3 here. When I square 2x, keep in mind I'm squaring the 2 and the x, so that becomes 4x squared plus 6x plus 9. The sum of cubes is very, very similar. And that is obviously when I'm adding two terms that are cubed. When we factor this, it becomes a plus b times a squared minus ab plus b squared. I'd like you to notice that both with the difference of cubes and sum of cubes, the first sign here is always the same. The next sign is always the opposite, and this one is always positive. So because there's a plus sign here, I have a plus sign there. If there's a minus sign here, there's a minus sign there. This sign is always the opposite of the first one, and the last one is always positive. Let's go ahead and do this example. If I have x cubed plus 64y cubed. Again, we want to ask ourselves, what would I cube to make x cubed? And the answer would be x. And then what do I cube to make 64y cubed? The answer would be 4y. So we have identified what our a and b are, and we can use these in our formula. So we're going to have x plus 4y here, and then x squared minus 4xy plus, keep in mind we're squaring the 4 and the y, 16y squared. So these identities are fairly important, and they do come up fairly often in this math class and in future math classes. Now, when you take trig next year, you're going to be doing a lot of work with identities. So we want to do a little bit of practice on proving identities. To prove an identity, you start with the expression on one side of the equation and use the properties of operations to transform it into the expression on the other side. So let's do an example here. Let's say that we want to prove that a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And that would be this property right here that we're proving. Well, what we would do is we would take the a plus the a, and we would multiply it times everything that we have here. So a times a squared would be a cubed. A times negative ab would be minus a squared b. And here we would have plus a b squared. Keep in mind from what we learned on the last lesson that we also have to multiply the b times everything. So we would have plus a squared b for our first term, and then we'd have minus a b squared for the second one, and then plus b cubed. If we line everything up, we can see that these two terms cancel each other out, and we're left with a cubed plus b cubed. So the way that you prove a polynomial identity is by using operations on one side to show that you are equivalent to what you have on the other side. Let's use some identities to multiply. In example 2, let's take a look at 2x squared plus y cubed all squared. So this is similar to the square of a sum that we talked about on the last page, where we said that a plus b squared is equal to a squared plus 2ab plus b squared. If we can evaluate what our a is, in this case our a is 2x squared and our b is y cubed, we can use this formula here to calculate what we would get when we square this binomial. So I want to take 2x squared and square it. And then I want to take 2 times x squared times y cubed. And then I want to take y cubed squared. So I'm basically just plugging in a and b to the formula. Again, distribute the 2. So that would be 4x to the 4 plus 4x squared y cubed plus, and if we take y cubed and square it, we're going to get y to the 6th. So that's a little bit nasty looking, but it's not as bad as it could be using the formula that we learned just a minute ago. Okay, let's try another example here. Let's use DOPS to multiply 41 times 39. This is kind of cool. If we want, we can think of this as a plus b times A minus B, or 40 plus 1 times 40 minus 1. I know that according to DOPS, that is going to be the same as 40 squared minus 1 squared, which is 1,600 minus 1, or 1,599. Again, this is because right here, this is A plus B times A minus B, which is equivalent to A squared minus B squared, which is what I'm using right there. Okay, we can also use polynomial identities to factor and simplify. So for example, let's say I want to do 11 cubed plus 5 cubed. Obviously my A is 11 and my B is 5. Using the sum of cubes formula, I know that the sum of cubes, if this is A cubed plus B cubed, the sum of cubes is going to be A plus B times A squared minus AB plus B squared, which is going to be 11 plus 5 times 11 squared minus 11 times 5 plus 5 squared. 11 plus 5 is 16. 11 squared is 121 minus 55 plus 25, or 16 times 91, which is the same thing as 1,456. Okay, that is just kind of like the bare bones essential of the identities that you need to know, as well as a few of examples similar to what you might see in the homework. Please do remember that we're going to take time to go over this in class, and then also just to do the 3.3a problems on your assignment. Thanks, guys. Bye.